Alright, so this is section 105 and 1.6, solving inequalities and absolute values and inequalities. Um, so remember, inequalities is greater than, less than, equal to, or less than or equal to. So if we have an x greater than, in this case we have a 4, if we was to write this on the number line, let's call this 0, 1, 2, 3, 4, 5. I'm going to change that. We're going to have an open circle. Oh, let's call this 1. 6. We'll have an open circle at 4, and it's going to go to the right. So I'll just change that. We'll have an open circle at 4, and we're going to go to the right. That's greater than. Then if we had greater than or equal to, we had the same number line. 1, 2, we would have a closed circle at 4, and the greater than or equal to, the equal to part says that it also includes 4. If it's greater than, it starts at 4 but doesn't include. So this is greater than or equal to. If we have x less than 4, have this number line. Let's put 4 here. 4, 3, 2, 1, 0, -1, 5. We would have an open circle at 4 and go to the left. So this is less than. And if we had x less than or equal to, and this is all from left to right when we do our number line. 6, 1, 3, 1, 0. We would have a closed circle because it includes 4 and goes to the left. So this would be less than or equal to. So greater than, open circle because it starts at 4 but does not include 4 and goes to the right. Greater than or equal to, it starts at 4 and it's a closed circle, meaning it includes 4 and goes to the right. Less than, open circle at 4, again starts at 4, does not include 4, goes to the left. Less than or equal to, starts at 4, it's a closed circle, so it starts at 4, it includes 4 and goes to the left. Okay. Certain phrases that you might need to familiar yourself with. At least or at most. Those are the ones that people get the most confused with. So at least means greater than or equal to. Okay, greater than or equal to. The other one that people get confused with is at most. That's less than or equal to. They're sort of counterintuitive because the least you think of less than, but it's really, I think of it as top and bottom. At least means it's the smallest number it can be. So it's already at the bottom, so you have to go up. At most, to me, I think about it's the highest number it can be. So it has to be everything less than that or below it. So in things of word equations, it says the quotient of a number is no more than 15. Okay, no more is another one of those counterintuitive ones. So it can't be any more, meaning at most. So it's the same thing as saying less than or equal to. So the problem says the quotient. Quotient means to divide. So the quotient of a number and 3 is no more than, so it has to be at the top, less than or equal to 15. Multiply both sides by 3, we get that n is no more than 45. So that would be our answer for got it, number 1. Now they give us a whole bunch of rules. Transitive property of inequality, which says that if A is greater than B and B is greater than C, then A is greater than C. So the example that the book gives, which is a good one, we have if 5 is greater than 3 and 3 is greater than 1, then 5 is greater than 1, which makes a lot of sense. I'm not going to write all of these down because these are sort of review. Addition property of inequality, if I have A greater than B and I add the same number to both sides, then A plus B will be greater than A plus C. Actually, I think I will. So the book uses 4 is greater than 2. So this is addition property of inequality. Addition property. Actually, addition property of inequalities. So we have if A is greater than B, then A plus C is greater than B plus C. So 4 is greater than 2, then 4 plus, what the book does also, I guess they consistent. 4 plus 1 is greater than 2 plus 1, which makes sense because 4 plus 1 is 5, and that's going to be greater than 3. Alright. Subtraction property of inequality. Subtraction property of inequality states that if A is greater than B, then A minus C is greater than B plus C, or B minus C. So if 7 is greater than 4, then 7 minus 3 is going to be greater than 4 minus 3. 4 is greater than 1. So that is correct. I'm going to go through these really fast because they're sort of review. Multiplication property of inequality, if A is greater than B, and C is greater than 0, then A times C is greater than B times C. Likewise, if A is greater than B and C is less than 0, then A times C is greater than, less than b times c. Alright, so these are two examples. So basically what it's saying is multiplying by a negative number switches the inequality. So if we have the book gives 6 is greater than 5, and they multiply it 6 times. 3. 3 is greater than 0, so 6 times 3 will be greater than 5 times 3. This is 30, 18. This is 15, so that works. Or, if 6 is greater than 5, and it's being multiplied by negative 4, 6 times negative 4, the inequality is going to flip. So it's going to be less than 5 times negative 4. 6 times negative 4 is negative 24. And this is negative 20. So guess what? It's less than. Same thing with the division property of inequality. If I divide by a negative number, then the inequality is going to flip. So for the division property of inequality, if A is greater than B and C is greater than 0, then A divided by C is greater than B divided by C. However, I should have did this in red. If A is less than B and C is less than 0, then A divided by C is going to be less than B divided by C. So we have the book gives 9 is greater than 3. So, and 3 is greater than 0, so nine divided by 3 is going to be greater than 3 divided by 3, which is true because 9 divided by 3 is 1. 3, and 3 is greater than 1. If I have the same, if I have 12 is greater than 6, and I'm dividing by negative 6, 12 divided by negative 6 is going to be less than 6 divided by negative 6, because 12 divided by negative 6 is negative 2, and negative 2 is less than 6 divided by negative 6, which is negative 1. So when you divide or multiply by a negative number, the inequality is going to switch sides. They give you a reason why, but I'm not getting into that. Okay, solving and graphing an inequality. So if I wanted to solve and graph the solution, here I have negative 2 times x plus 9 plus 5 is greater than or equal to 3. First thing I'm going to do is subtract 5 from both sides. That gives me negative 2x plus 9 is greater than or equal to negative 2. Then I'm going to divide both sides by negative 2. And that gives me x plus 9. The inequality flips, less than or equal to Negative 1, subtract 9 from both sides. And I get x is less than or equal to 10. And then when I graph it, negative 10, I'm sorry. Yeah, 10, 12. I would have, since it's an equal sign, I have a closed circle. I would have a closed circle and go to the left. Alright. Digital music service offers 2 subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. How many songs must you download for the second plan? The cost less than the first plan. Okay. The first plan offers a $9 membership fee and charges $1 per download. The second one charges a $25 membership fee and 50 cents per download. And they want to know how many songs you need to download for the second plan that costs less than the first plan. So this would be the first plan. This would be the second plan. They want the first plan to be less than the second plan. Alright, so when I set this up, I'm going to substitute the first plan with 9 plus 1x, or 9 plus x. I'm going to substitute the second plan with 25 plus half of x. I'll just do 1 half x. Same thing. Subtract 9 from both sides. X is less than 16 plus 1 half x. Multiply both, subtract both sides, 1 half from both sides. Half x. That goes bye-bye. Half x is less than 16. Multiply both sides by 2. And I have x less than 32. So I can rewrite it and say 32 is greater than x. So you have to sell more than 32 movies in order for this to work. Or 32, whatever they want. Not movies, downloads. Less than 32 downloads. Alright, moving on. Alright, no solution, real solution, blah, blah, blah. Okay. So, I'll go through these. If I have two inequalities and I'm solving, I can have something that's always true, never true, or sometimes true depending on the situation. So for an example of never true, the book gives, which is negative 2 times 3x plus 1 is greater than negative 6x plus 7. First thing I'm going to do is I want to solve for x, right? And I'm going to have to think the best thing for me, since if I divide by 2 I'm going to get a funky fraction, is I am going to distribute. I have negative 6x minus 1 is greater than negative 6x plus 7. Yes, this is the route to go. I'm going to add 6x to both sides. The negative 1 drops, the greater sign drops, and the 7 drops. Negative 1 is not greater than 7. So this doesn't exist. This is never true. For the other example, negative 5 times 2x minus 3 minus 7x greater than or equal to 3x plus 8. Alright, I'm going to use the distributive property. 10x minus 15 minus 7x is less than or equal to 3x plus 8. I can combine like terms and I get 3x minus 15 is less than or equal to 3x plus 8. Subtract 3x from both sides. I get negative 15 is less than or equal to 8. This this is true, so this will always be true. So it's never when the inequality doesn't make sense, and then it's always when inequality is true. When is it sometimes? It's only sometimes when it's going to be x is less than something, or x is greater than something, or equal to something, so or of the like. So this would be the sometimes scenario, just in case you were wondering. All right, so the example that the book gives is, I want us to try, is 4 times 2x minus 3 is less than 8 times x plus 1. Is it sometimes, always, or never? I do the distributive property here. Actually, no, I won't, because these will divide evenly amongst. I'll divide both sides by 4. That goes away, and I get 2x minus 3 is less than 2x plus 1. Here I can use the distributive property. 2x plus 2, subtract 2x. The negative 3 drops, the inequality less than drops, and 2 drops. Negative 3 is less than 2, so this will always be true. Compound inequalities. So we have an and. If you have an and, we're going to have a situation where we have some line that goes this way, inequality. We have some other line. I'll try to be color coordinated with the book, which goes this way. And where they intersect is your compound inequality. So we have some number line, I'll just say between 0 and 5. This is the part where this is an AND scenario. This is the part where they both exist at the same time. or you can think where they intersect. Either way. Okay? They're both true or they both exist at the same time. Alright? So for this particular example, they want us to do the 5 is less than or equal to 3x minus 1. I'm going to add 1 to both sides, which is 6 is less than or equal to 3x. Divide both sides by 3. And we have that 2 is less than or equal to x, or we can say that x is greater than or equal to 2. That's scenario number 1. Scenario number 2, they give us 2x is less than 12. We could divide both sides by 2. We can say that x is less than 6. So that's our second scenario. If we was to graph that on a number line, we have 2 and we have 6, so let's do 1, 2, 3, 4, 5, 6, 7, 8, 9. First part we have is, oops, that's not right. As we can say is x is greater than or equal to 2. So here's my 2. It's a closed circle. So you're going to go that way. The other guy is going to be x is less than 6, and it's an open circle. So it's going to go that way. And this is where they intersect at the same time. So we're going to have, to graph this, closed circle at 2, going to 6, and having an open circle. So we can say that x is greater than 2, less than 6. Greater than or equal to 2 rather, and less than 6. They ask us if the compound inequality is always true, sometimes true, or never true. This is going to be sometimes true, only when x is greater than or equal to 2 and less than 6. Alright, solving an OR inequality. So these are examples of AND inequality. So remember, AND is where they intersect. Alright, so when we deal with the OR inequality, they're graphing and they're going in different directions and they're not intersected at all. So this is how we graph it when they're not intersected. When they're not intersected, I have, the book gives me 7 plus k is greater than or equal to 6. Then it says or 8 plus k is less than 3. Okay, so graphing this, I'll put it in blue. So graphing this, solving, I'll subtract 7 from both sides, and this is k is greater than or equal to -1. this is k is less than -5. Okay, so when I graph these bad boys, I have -5, -4, -3, -2, -1, 0, 1, -6, -7, -8. K is less than or greater than or equal to 1. So if it's greater than or equal to 1, it's a closed circle at 1 and it's going to the left, greater than or equal to. If I have less than or equal to -5, it's an open circle and it's less than, so I'm going to the left. Notice they don't intersect. This is an OR situation. And that was how I would graph it. Alright. So the two examples they want us to do is A, 7W plus 3 greater than 11. Subtract 3 from both sides. Are you kidding me? Why are you gonna give me a fraction? Oh, I wonder if that was a typo. Subtract 3 from both sides when we have 7W is greater than 8. Then divide by 7, we have W is greater than 8/7. Well, isn't that wonderful? That's what, 1.14. That's splendid. And let's do the other one. So 4W minus 1 is less than -13. Add 1 to both sides. 4W is greater than -12. Multiplied by 4W is less than -3. Okay. So when I graph this, -6, -5, 3, -2, -1, 0, 1. I don't know why I keep doing that too. Change these numbers because I put too many negatives. -5, -4, 3, -2, -1, 0, 1, 2, 3. Much better. I have an open circle at 3. So I have an open circle at 3. And I'm going, W is going to be less than, so it's going this way, -3. I have for W greater than 8/7, which is like 1.1, I have an open circle here, and it goes that way. Remember, these are OR situations. They don't tend to intersect. Alright, so that's A. So let's look at B. For B we have 16 less than 5x plus 1. Subtract 1 from both sides. 15 is less than 5x, which gives us 3 is less than x, or we can say that x is greater than 3. Okay. the other side, we have 3x plus 9 is less than 6. Subtract 9 from both sides. 3x is less than negative 3. And then x is less than negative 1. Yeah. Negative 1 to 3. So when I graph this bad boy, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5. Alright, x is greater than 3, so I have an open circle at 3, and I go that way. X is less than negative 1, open circle at negative 1, and I go that way. Again, these are OR situations. So when they're ORs, we graph everything, and it's every solution that makes it true. So when it's OR, you graph everything. When it's AND, you graph the intersection. Okay, so that's section 1.5. I hope you have a great rest of your day.